Everyone, we're going to continue to go over the review packet for our trigonometry unit. And this right here is page 3. All right, so number 5. A ladder 25 feet long is leaning against a house. Okay, so here's our house. Here's our ladder. Okay, we're going to assume your house is at a 90-degree angle. So 25-foot ladder. If the foot of the ladder is 7.3 feet from the base of the house, what is the angle formed by the ladder and the ground to the nearest degree? Okay, so we have an adjacent, we have an hypotenuse. So again, our SOHCAHTOA tells us that we are using our cosine function. All right, so we have the cosine of x equals my adjacent over my hypotenuse. So I'm going to go to my calculator. Okay, again, we're using our second cosine function. 7.3 divided by 25. And it said to the nearest degree. So x is approximately 73 degrees. Number 6. You're holding a kite 3 feet above the ground. The string of the kite is making a 25-degree angle with the horizontal, and you've let out 100 feet of string. How high above the ground is the kite to the nearest tenth? All right, so whatever we get for our x, we have to remember that we're also 3 feet, right, from the ground. So whatever we get for our answer, we're going to have to add 3 to. Okay, so this is going to tell us we have an opposite. We have a hypotenuse giving us our sine function. So sine of 25 degrees gives me my opposite over my hypotenuse. Cross multiply. Pull out the calculator. 100 times the sine of 25. All right. And we get about 42.3 feet. Now we have to add this 3 in there. Okay, so the actual height is going to give us 45.3 feet. Okay, because we add our 3 there. All right, number 7. Number 7, a ship sights the top of a cliff 250 feet above sea level at an angle of elevation of 32 degrees. 20 minutes later, the angle of elevation of the ship now is 41 degrees. Okay, so the ship is going this way. How far did the trip travel in those 20 minutes? Okay, so we need a couple of different things. All right, so what we need to find really is we need to find this distance right here, x. But unfortunately, we only know how to deal with right triangles. All right, so what we're going to have to do, though, is we're going to have to find this. All right, if we find this big length here, and then we take away this length that we can find here, we'll be left with our x value. All right, so we're going to work with 3 variables here. And so the first thing we're going to do is we're going to try to find, let's find z first. Okay, so this over here is an opposite. All right, and I'm looking for all of these sides here are going to be adjacent. All right, so we're going to be using our tangent function. All right, so we have the tangent of 32 is 250 over z. All right, so z is really 250 over the tangent of 32. Okay, I'm actually just going to leave that like that for a moment. Okay, so now what I want to do is I want to deal with this guy. All right, so we're going to say now that we have the tangent of 41 is 250 over my y value. So y is really 250 over the tangent of 41. All right, now we said in the beginning that x was really equal to the z if I take away the y. So my x is really 250 over the tangent of 32 minus 250 over the tangent of 41. All right, now I could have put all these in and had decimals here. It's just kind of a matter of preference. All right, and let's see. I've got 250 over the tangent of 32 minus 250 over the tangent of 41. And I get 112. And let's see, you wanted this to the nearest foot. So x is approximately 112 feet. All right, number 8. Find the value of x. Okay, so remember we have a sine, and cosine, right? These are co-functions. And co-functions have angles that are complementary. Okay. All right. So what I know then is if these are equal, that together, x plus the 43 has to be 90 degrees. So my x is 47 degrees. All right. So again, cosine and sine, co-functions are complementary. So now I'm just going to solve my equation. And my x value then is 11. All I have to do is solve for x. I could plug that in my calculator and double check. All right, and number 9. Y is the sine of 70 equal to the cosine of 20. All right, so the reason that we have this, okay, is since the angles are complementary, okay, when we think about having a right triangle, right, if we had a 70 and a 20 here, right, well, if I had the side adjacent right there, right, let's just call these, let's say it's like an A, a B, and a C, right? So sine of 70 is really B over C. Now, if I talk about the cosine of 20, that's also B over C. So since the angles are complementary, we're going to run here. The side, I don't want to write that. Let's move it maybe over here. The side adjacent to one angle is opposite the other. In the right triangle. All right, well, that's the end of page 3. Stay tuned for page 4.